Welcome to The Explainer. Today, we are pulling back the curtain on something that powers just about everything you do online. We're talking about the deep-down fundamental philosophies that dictate how we organize, store, and find all the world's information. Let's jump right in.
So have you ever stopped to think about this? Seriously, how is it that your bank can track every single penny with perfect, flawless accuracy, while an app like TikTok can somehow juggle a tidal wave of videos, comments, and likes for billions of users all at the same time? Well, it turns out it's because they aren't trying to solve the same problem. And that leads to two completely different ways of thinking about data.
Okay, let's lay the groundwork. Underneath practically every app, every website, every piece of software you touch, there's a system working tirelessly to keep things in order. And that system is, you guessed it, a database.
At its most basic, a database is just that, a collection of information. But the magic words here are organized, retrieve, and update. You see, how a system decides to handle those three things, well, that defines its entire personality, its entire philosophy. First up, let's enter the kingdom of structure. This is the traditional, classical world of relational databases. I'm talking about the bedrock of computing, going all the way back to the 1970s. The best way to picture it? Think of a massive, meticulously organized library, where every single piece of information has a very specific, pre-assigned spot on a shelf. So, this world of absolute order starts with a super strict blueprint. It's called a schema. And before a single piece of data can even enter the library, this schema lays down the law. It defines what we're storing, what it looks like, and how it all connects. It is the absolute, unquestioned source of truth. The first building blocks of this blueprint are what we call entities. You can just think of them as the main nouns in our data story. They're the real-world things or concepts we actually want to track. Like a student or a department. Now, each of those entities needs some description, right? That's where attributes come in. For our student entity, the attributes would be things like their name, their student ID, their address, all the essential details that make them them. And finally, the really powerful part. We connect these entities together with relationships. This is how we show they're associated with each other. For example, an employee entity is connected to a department entity through a relationship called works in. All of a sudden, we don't just have lists of things, we have a logical, interconnected web of information. All right, so we've got this amazing, highly structured library, but how do we stop it from getting messy? How do we prevent ourselves from, say, shelving the same book in 10 different sections by mistake? Well, there's a special process for that, and it's called normalization. I mean, that's the core question, isn't it? The whole point is to stamp out data chaos before it even starts. We want to get rid of wasteful repetition and make sure our data is structured so logically that we don't cause a catastrophe every time we need to add, update, or delete something. Normalization is basically just a step-by-step cleanup routine. The first rule is simple. One piece of info per box. You can't stuff multiple colors into a single cell. Then, the next steps are all about one big idea. Don't repeat yourself. For instance, instead of writing out your department's address next to every single employee who works there, you store that address once in a separate departments table. Why? Because if the department moves, you only have to change it in one place, not 1,000. It makes the data cleaner, leaner, and way less likely to break. And the ultimate prize for all this hard work, for all this structure and tidiness, is the ACID guarantee. This right here, this is what powers your bank. It's a promise that every transaction is atomic, meaning it's all or nothing. Consistent, the rules are never broken. Isolated, two transactions can't trip over each other. And durable, once a change is saved, it's saved for good. It is absolute, bulletproof reliability. For decades, this kingdom of structure was king. It was untouchable. But then, the internet happened. And it wasn't just big, it was an explosion. Suddenly, we were drowning in data that was messy, unpredictable, and changing at lightning speed. We're talking social media posts, sensor data, you name it. The old world of perfect order just wasn't built for this new scale of glorious chaos. And this is where the pivot happened. The old relational systems, they kind of choked on the messy, nested data of the web, and they weren't designed to be spread out across hundreds or thousands of cheap servers. So a new philosophy was born, NoSQL, which, fun fact, really stands for not only SQL. It threw out the rule book. It's flexible. It doesn't need a rigid schema up front. And it was born and raised for the massive web-scale world.
Now, NoSQL isn't just one thing. It's a whole family of different tools for different jobs. You've got key value stores, which are basically like a giant, super fast dictionary. You've got document databases, which let you stuff complex, flexible information into a single record, kind of like a digital filing cabinet. There are column family stores built for ridiculously fast analysis of huge datasets. And then you have graph databases, which are all about understanding complex webs of connections, think social networks.
This new world of flexibility and scale is unbelievably powerful. But it comes with a cost. It introduces a fundamental conflict, an unbreakable law of physics for distributed data that every single engineer has to wrestle with. Because here's the catch. You get all this amazing new power and scale with NoSQL, but you can't have it all. There's no free lunch. You are forced to make a very difficult, very fundamental choice about what you value most.
And this choice has a name, the CAP theorem. It's not a guideline or a best practice, it is a proven mathematical theorem. It states that for any system with shared data spread across multiple machines, you get to pick 2 of 3 guarantees. That's it. You cannot, under any circumstances, have all 3.
So what are the 3 options on the menu? First, you've got C for consistency. This means everyone, everywhere, sees the exact same, most up-to-date data always. Then there's A for availability. This means the system is always online, it will always give you an answer, no matter what. And finally, P for partition tolerance. This means the system keeps on chugging, even if the network breaks and some of your servers can't talk to each other. This quote really nails the core dilemma. In the real world, networks fail. It's not an if, it's a when. So you have to design for partition tolerance. You have to choose P. Which means you're left with a stark choice. Do you want perfect consistency, or do you want perfect availability? Do you want to always be online, even if that means you might occasionally serve up slightly stale data? Or do you want to guarantee your data is always perfectly fresh, even if that means you have to sometimes tell a user, sorry, try again later?
So which side is better? The kingdom of order or the revolution of flexibility? The truth is, that's the wrong question. Neither is better. This isn't a story of good versus evil. It's about being a smart engineer and choosing the right tool for the job you have in front of you.
And this really sums it all up. On one hand, you have the relational world of order. It gives you a rigid, predefined schema and rock-solid ACID consistency. It scales up by buying a bigger, beefier server. It's perfect for banking, healthcare, or e-commerce, where you absolutely cannot afford a single mistake. On the other hand, you have the NoSQL world of flexibility. It has a dynamic, come-as-you-are schema and lets you tune your consistency. It scales out by just adding more cheap servers. It's the go-to for social media, big data analytics, and the Internet of Things, where speed and massive scale are everything. So, the next time you open an app, just take a second and think about the choice its creators had to make. Did they build their world on the unshakable certainty of order, or did they bet on the explosive power of flexibility? Because understanding that one single trade-off, that's the key to understanding how our entire digital world actually works.